There are three different types of external EGR systems. The oldest type is a vacuum-controlled EGR. It consists of a vacuum valve and an electromagnetic valve. The engine control unit of the engine through the electromagnetic valve controls the operation of the vacuum valve, which opens and closes the exhaust gas flow into the intake manifold. The vacuum-controlled EGR valve contains a membrane that separates the two chambers. If necessary, a vacuum or external air is supplied to one chamber from the electromagnetic valve, which acts on the diaphragm together with the spring. A valve lever is attached to the other end of the diaphragm. At the lever end is a pintle valve for closing the exhaust gas recirculation channel. When there is outside air in the upper chamber, it together with the spring pushes the diaphragm and closes the EGR valve. By creating the conditions for the EGR valve to open, the engine control unit supplies voltage to the solenoid valve, which is switched to the position to pass the vacuum. A vacuum enters the upper chamber instead of outside air. Due to the weaker pressure, the diaphragm rises and opens the valve for the exhaust gas flow. When the conditions for exhaust gas recirculation are disrupted, the engine control unit power supply is cut off. The solenoid valve switch closes the vacuum supply and allows outside air into the vacuum valve. Pressure rises in the upper chamber. Higher air pressure pushes the diaphragm and closes the valve, stopping the exhaust gas flow to the intake manifold. So, when a vacuum is supplied from the solenoid valve, the EGR valve is open and we have exhaust gas recirculation. When outside air is supplied, the EGR valve is closed, and we have no exhaust gas flow into the engine intake manifold. The disadvantage of the vacuum EGR valve is that it only has two states, open and closed. Thus, there is no possibility of regulating the exhaust gas flow between these two states. Another type is electric, linear EGR valves. They can regulate the amount of exhaust gas, making them more suitable for more precise and comprehensive recirculation control. It is a single device that contains an electric drive and a valve. There are two types, electromagnetic and with a stepper motor. With the electromagnetic EGR valve, a spring closes the valve. The valve armature is outside the electromagnet. When power is applied to the coils of the electromagnet, a strong magnetic field is created inside the solenoid coil that pulls in the armature, compressing the spring. Then the EGR valve is open. The solenoid valve is powered by PWM signals from the engine control unit via a 2-pin connector. The longer the opening period of the PWM signal, the stronger the magnetic field and the more the valve opens. When there is no power, the spring closes the EGR valve. With the second type of linear EGR valve, positioning is done using a stepper motor. The valve opening is in steps. The stepper motor is powered from the engine control unit via a 6-pin connector. Depending on the combination of the power supply of the different coils, the electric motor rotates and takes an appropriate position. By rotating the armature, the valve opens and closes in steps. With the first EGR valves, the engine control unit had no feedback on whether exhaust gas recirculation had occurred. Service technicians often close the return line, and no matter that the ECU opens the EGR valve, there is no exhaust gas flow. That is why the legal regulations were tightened, which required control of the correctness of the EGR system by the engine control unit. Manufacturers have solved this requirement by adding control functions of pressure analysis in the intake line through the MAP sensor, analyzing the signal from the oxygen sensor, and installing a valve position sensor in the EGR. Now the ECU can control the correct operation of the EGR valve and the performed exhaust gas recirculation. The ECU detects any blockage, disconnection, or failure of the EGR system. It stores an error code, turns on the malfunction indicator lamp, and the engine runs with a limited maximum number of revolutions because the exhaust gas emission is increased. This limited engine function allows the driver to take the vehicle to a car repair shop. Some vehicles also have a digital type of EGR valve. It consists of 2 or 3 electromagnetic valves that control the opening of openings of different sizes. The engine control unit controls the opening of each solenoid valve individually. When a solenoid is energized, its plunger is lifted, and exhaust gas can recirculate through the orifice into the intake manifold. The computer controls the total amount of exhaust gas through the valve opening combination. The question arises whether the EGR valve is necessary for an internal combustion engine because it works normally without it. The EGR valve was introduced to reduce the concentration of nitrogen oxides in the exhaust gases as a dangerous component that leads to health problems and causes cancer of the respiratory organs. In addition, in a partial load state, it lowers the engine temperature and reduces fuel consumption. Finally, EGR is required to comply with the legal norms on exhaust emissions. Driving with a faulty EGR valve is punishable. That's why EGR is necessary for ourselves and the people in our environment.